Today, welcome to this session. We are going to hear from two presenters, definitely. We have Miriam Olivares from Yale. She's going to deliver a presentation on a geo-inspiring kind of a remote biological laboratory during the pandemic. So in the fall, she had about 64 students facing a remote learning experience or challenge, and she felt the need to reimagine the program. So she's going to talk to you more about that, and we'll get her started here. After that, we'll hear from Dr. Torro from De Anza College. Dr. Torro is an environmental educator committed to equitable, inclusive, and fun learning space. So transitioning abruptly to a digital learning space was surprising, and definitely she needed to kind of reinvent her classroom a bit. So she's going to talk about what she did as a means to communicate environmental science messages. So, and then hopefully we'll hear from Dr. Salip Aika about her work with, as the title is called, Mappy Python Diaries on Jupyter Notebooks, and revamping her GIS Python programming course. So let's get started, and I will hand the reins over to Miriam.
Thank you, Rich, and I will ask my colleagues, Dr. Maria Moreno and TC Chakraborty, to turn on your cameras, please. And I'm gonna start sharing the, okay. Just give me 1 second because I'm dealing with two screens, so. Okay, so hopefully Dr. Moreno and TC are on camera. Good afternoon, everyone. My name is Miriam Olivares. I'm the GIS librarian and coordinator of the GIS Support Services Hub at the Yale University Library. I am super excited to join this session along with Dr. Moreno, research scientist and senior lecturer at the Department of Molecular, Cellular, and Developmental Biology. Yes, she's doing GIS at her classroom. And TC Chakraborty, PhD candidate in the Yale School of Environment, and also just special consultant in the library. Today we will be sharing why and how we developed the Geospatial Learning Accelerator for Biology. And I'm gonna time myself, I'm sorry about that. This accelerator was developed for a biology lab. The course is called Model Organisms in Biological Research. So the collaboration happened between Dr. Maria Moreno, the instructor for this lab, the Yale Library Support Service, which TC and I represent in this case, and instructors from the Esri Learn RGS team. We are very grateful to Angela, Ryan, and Colin, who devoted to this experience and give us their expertise in the classroom. And also want to thank Riley Pick and Sirisha Karamchedu for their support to embark on this project. Several teaching fellows also joined the effort and contributed to the training. What happened is we got together, Dr. Moreno will explain more, but the accelerator followed kind of a half of the semester where Dr. Moreno taught quantitative reasoning instruction, and then the Yale GIS team joined to taught GIS Foundation, hands-on RGS Online training, and provided high-impact GIS consultations that integrated the teaching beyond the classroom. Then the Esri Learn RGS team joined to teach more concepts in GIS, spatial analysis, visualization, and integrated their RGS Learn lessons, as well as a lot of improvisation on the fly to make this happen and to fulfill the GIS analysis required to accomplish the goal of the accelerator. So We offered the accelerator during 6 weeks to 64 undergraduate students in 4 sections, lots of students, meaning once a week. Only for them, it would be once a week, 3 hours per class. The student had to select a topic they deeply care about and base their research on lead review. That was a skill that they learned from Lori Bronner's, a Yale life science librarian. We selected the story maps as the way to deliver their project and findings, because we have learned even from big team researchers and teams that they have found that the story maps are kind of the best way to put everything in a concise way to have a compelling story and disseminate the findings. Now, Dr. Moreno will tell you everything about this wonderful experience we had as instructors. Dr. Moreno? Hopefully you have audio.
Yes.
Okay, wonderful.
So as a laboratory instructor, my goal is to provide my students with research competency skills. My main tool of instruction is the scientific method. Shown here is a depiction of the process involved. In general, observations, explanations, and experiments form an interconnected circle. Reasoning can be going from general to specific and vice versa. Testing theories, however, moves from the specific to general direction, and it is of pivotal importance to determine what the purpose of the experiment is, to define the experimental control and the control groups, define the variables studied, choose the best fit experimental design strategy. This is incredibly important because results cannot be evaluated if the process of the data generation and analysis is not fully understood. One important consideration is that regardless of the type of research being done, the research process has essentially the same scaffold. Next. As an instructor, I also need to have a well-defined set of teaching objectives, which also includes understanding my pupil population. Participants in this class range from incoming freshmen to graduating seniors. Everyone is at a different point in their independent learning process. We can consider common ground the fact that they have a somewhat developed knowledge base that is beginning to become expanded and more specialized as they begin to discover their interests and passions. Our job as teachers, however, is to tap onto that knowledge base and catalyze the expansion in a way that the students have the opportunity to share their teaching, their learning, and at the same time increase their knowledge base in a guided manner. Next. So using the Bloom's taxonomy, which is a hierarchical framework for cognition and learning, my goal is to help the students advance to the application, analysis, synthesis, and evaluation phases of the learning framework in a way that they can become better thinkers and content creators. Next. The activities in the laboratory classroom are designed to increase their knowledge base through a common assignment while practicing the application, analysis, synthesis, and evaluation processes in an individual as well as a collaborative manner. Next. Next.
Yes, sorry.
So in the typical lab classroom, the students would be performing experiments with sophisticated equipment, making and recording observations. Next. The data recording process, however, incorporates collaborative platforms such as Google Drive. This is an example where 4 students are collaborating in a data collection process. The data is being recorded in real time and the participants have access to the complete data set and an opportunity to vet all the numbers. Next. They also have an opportunity to learn to visualize data in a way that the trend can be observed. Next. They also learn to select the best statistical method and graphic instrument to report their findings. When COVID-19 struck, the world became our laboratory classroom. The students applied the scientific method to a research problem of their choosing that had a biological component. The steps of the investigative approach are outlined here. Students surveyed data sources, narrowed the subject and scope, did data collection and analysis, and mapped and visualized their data. For the success of these activities, it was important to be able to integrate the teamwork aspect of the laboratory classroom. Next. For ideation and project outlining processes, the collaborative whiteboarding platform Miro was the tool of choice. After a brief training, students were able to work effectively and use the most of the whiteboarding tools available through the platform. Next, the ideation boards became more than a brainstorming tool. They were a data depository, a discussion forum, and an idea organizing and workflow management tool. All these components were essential for their success in their projects as well as for fostering their skill set growth. The outcome of this project was 14 fantastic story maps that illustrate the passion of our students to understand and propose solutions to the complex problems of our world. I was successful in preparing my students for the initial data sourcing and basic quantitative reason of the projects. The Esri Learn team provided specialized instruction on ArcGIS Online, and the GIS division of the Yale University Library provided one-on-one consultations with the students to provide additional support to data analysis and the reporting steps of the process. This combination of resources proved to be very successful and a very effective approach.
Thank you, Maria. I'm gonna take over from this slide. Hello, everyone. So as part of the GIS support services, my role was meeting with the students for consultations, where I would help them both to find the right data and improve their analysis and data visualization skills. So some of them would come individually and some of them would come in groups. So I'm going to talk about a few of the interesting projects that came out of this course and the visualizations which I personally find very interesting. Miriam, next slide, please. Next slide.
Yes, it's there.
Yeah. So we had a project on the opioid epidemic in the US, and this map, for instance, shows the statewide opioid overdose deaths. And this is one of the 14 story maps that we had as part of the project. Next slide. This was another project which analyzed the disparities in birth outcomes by socioeconomic groups. Here you see chloroplasts showing distribution of birth rates by percentage of Black residents and social vulnerability index in Chicago. And you can actually use the slider to switch between the different layers. Next slide. And here is a dashboard. If you click on it should start playing, Miriam.
Oh.
Yeah. So yeah, here's a dashboard which shows the prevalence of adult asthma cases in Michigan counties. And you can kind of see the different interactive features available. And this was also not really taught during the class, but a few of the groups came to me to learn how to create the dashboards themselves. Yeah, this is not a, yeah, next slide. Yeah, yes, you have several visualizations in the dashboard itself. Finally, we have a visualization of heat maps of COVID-19 cases in the US Southeast, as well as cases in colleges. There are a few other layers, but I'm just showing those. So these were kind of an overview of some of the slides, some of the projects I found interesting and the visualizations. With that, I will give it back to Miriam.
Okay, thank you, DC, and thank you, Dr. Moreno. We are very pleased with the outcome of this GIS Learning Accelerator. The initiative received attention by decision makers and media from Yale University Library, the Yale Department of Molecular, Cellular, and Developmental Biology, and it was recommended to be featured in the main Yale News portal. That is a huge thing for us because I've been at Yale for 5 years, and it's the first time a project happens to get that. And even the Esri Learn team decided to add the gallery to their hub. For us, it was terrific to expose 64 undergraduate students to GIS and our services. 3 courses have contacted us after the accelerator to implement something similar. A student club started using GIS to measure energy consumption across campus. We are implementing a shorter version in STARS, a 27-year-old program at Yale that is for STEM retention geared towards underrepresented minorities. The Esri Learn team has joined us as well. For job placement, 3 students have reported they landed a job because of the GIS component. It's been invaluable to interact with these students with different academic backgrounds, bringing a very fresh perspective for us as GIS educators and GIS support services. And collaborating with a biology instructor has been a very unique experience for me. I really learn a lot. Thank you again to the Esri Learn RGS team, to TC Dr. Moreno, but mostly to 64 students who were completely committed to find solutions for their communities. And we will be pasting the links just so you can browse the story maps. As you can see, these students were never exposed to GIS before this class, so that's why we are so excited. Thank you. Back to you, Rich.
Yes, thanks, Miriam and team. Wonderful presentation. So now we're going to hand things over to Dr. Torro, and she'll be discussing her different approach, or pedagogical approach during the pandemic. Thanks. Dr. Torro, we just need to.
Yeah, sorry.
Yep. No worries.
You need to unmute before you share, apparently. Okay, so it's nice to be here with all of you at the ED conference this year. I thought this was a great opportunity for me to share with all of you some of the work that I've done with my colleagues at De Anza. Unfortunately, they can't be here today, but I thank them for their contributions. Just to let you all know, De Anza College is a California community college. It's one of the largest with a student population of almost 19,000. We're located in the southern San Francisco Bay Area. You probably know it better as the Silicon Valley. And we're surrounded by Apple and technology everywhere. So we have a really unique student population. We're so fortunate on our campus to have a beautiful platinum LEED certified building committed to teaching environmental science and environmental studies. So when the pandemic hit and forced all of us to be online, this was a really difficult thing for us because our space is provided and we go there and that's where we create community. So as we all know, in winter 2020, we are in the quarter system. So we were forced during the middle of the quarter to go online. Some instructors having no experience doing that before. We were given an extra week during spring break to prepare for our spring courses because we're quarter. We still had to do our spring courses, which, as I mentioned, it forced our face-to-face courses to now be online. And I thought this was a good opportunity to begin or continue and build on my use of story maps in my curriculum. So a little bit about myself. I have a bachelor's and master's in environmental science and management, and my doctorate is in education and organization and leadership. While I was studying for my doctorate, I began to have a better understanding of equity and empowerment and the intersection of that with environmental science. So I've had a really unique experience in my education, and I try to bring that to my pedagogy. One of the theories of pedagogy that I learned in my program was that of Paulo Freire, and it's called the pedagogy of the oppressed. The pedagogy of the oppressed is about acknowledging that students bring knowledge to the class based on their experiences in life, and that they are not empty vessels that I fill with information, but rather I encourage them to acknowledge and gain confidence around their own knowledge that they bring. We have a resource that I use. It's called The Little Piggy with a Big Idea. And if I share my presentation, you all can have the link. It's a student created kind of comic book story telling the story of pedagogy of the oppressed in a more digestible format for students. I use this in all my classes to let them understand that the way that I function is not that I am the one who has all the knowledge and I share it with all, but rather we learn from one another and I also learn from them. So in spring 2020, my colleague, Professor Frisbee, and I had to teach our conservation biology class. And obviously when we set out to teach this class, we didn't know that it would be online only. And I wanted to just share here what we had been doing the prior spring, which is we took another class of, I believe it was 20 students out to Santa Cruz Island, which is off the coast of Santa Barbara. We are not located anywhere near that. It was a huge trip. And that's what we're used to doing. We're used to taking students out to these places and getting them engaged in the environment and really watching them transformed. So we thought, how can we bring space-based learning and thinking into our digital classroom? So Professor Frisbee and I worked together, and we decided that a way for us to do this was to utilize one of the textbooks that we read, and that is the book shown here, When Mountain Lions Are Neighbors. The way that we did this is we had the students break into groups, and they each selected the chapter that they wanted to cover as a group. The chapters were, this is a great book if you haven't read it. It's about mountain lions in LA, porpoises in the Bay. There's all kinds of information about the really the collision of humans and wildlife. So the project at the end was for the students to create a story map and then share together. And this is ultimately the way that I run a lot of my classes. The students are going to communicate their learned information with one another. I create a digital space through the discussion where then they share. Oh, you all can't see my screen? Are we having a technology problem?
Perhaps you haven't shared.
I thought that I did. Hold on 1 second. I'm sorry. Better?
It is in working mode. It's not presenter mode, but we can see your slides.
Well, it was in presenter mode before. So now is it, are you still able to see it or is it gone?
It's
It's
loading.
loading.
It's loading.
I'm sorry. This will make more sense. So that's the map of the San Francisco Bay Area and our building. I told you all this. This is the pedagogy of the oppressed, student generated. This is just an image of it. There's actually a link here, which I'd be happy to share. This is us having fun in a normal order out on Santa Cruz Island. Now it's making more sense?
Yep.
Okay, good. Okay, so this is the book. This is the book that I highly suggest. What I did is I actually brought in images because I was worried about technical problems. So that shows how that works. rather than opening up the story maps, because sometimes that can be a burden with Zoom. This over here on the right is an example of one of the chapters that the students did. And what I really liked about this was a story map. I just pulled images off of it. But what I really liked about this one was that the students created this map of the journey of a black bear in Yosemite, which really brings into the class that visualization, the space, and the understanding. This is another one, just an image from an example of a student doing their final project on Alum Rock Park, which is a San Jose city park that is located, right on the east mountain range here, that is accessible to the majority of the students. So that also provides a way for students to share spaces that they like to visit, that they may want to encourage others to visit as well. Another thing that I did during that time, and what I've been doing for the last about 5 years or so, is encouraging my department faculty to get involved and to utilize the Esri products. So I reached out to all of them, and one colleague, Joshua McCluskey, who is not able to be here today, he is completing his master's in urban planning at San Jose State, replied and was very on board. It's really easy to get the faculty who already have GIS to participate. It's very difficult to get the faculty who don't understand GIS to participate. So Josh utilized in his environmental science labs the same concept. Students were encouraged, if they felt comfortable, to go explore and do observations on their own. And what you can see here is that a student did just that and created a map, as well as documented their own observations through the story map. Another thing that we did to create community is we held, because I think all of us were trying to figure out in a digital space, how do we create community? And we held what we called an environmental speaker series. And I utilized this as an opportunity to be a speaker at one of the events so that we could record it. And then I could use that in my instructional lessons to teach students how to make a simple story map. Because after spring 2020, what I really wanted to do was bring it into my asynchronous, all my classes. I teach environmental studies, environmental science, intro to sustainability. And I wanted to see if I put it out there as an option, would students utilize it, and would they, would they be able to do it with a very simple explanation? I don't explain how to add a map. It's just very easy, adding links, adding text, and organizing information in a visual way, because our students actually we don't have any prerequisites. So I have a very vast diversity of student capabilities. And I wanted to see if some students would maybe gravitate more towards this format. And I've seen some really great submissions come through the last year. I also have utilized story maps in my own class lessons. And as I mentioned earlier, we have a building on campus where we have beautiful gardens and beautiful space. And this has been a transition for students to not be in that space any longer, or to not even know about that space. So one of the things that I did this academic year is I created a story map about our building and the learning space, and I integrated in actually other story maps that students have done in and on our building. Here it is, yeah. So there's one about our open space area that was done by another student. And I brought in, we have some videos of students and faculty sharing. And then I led that into the introduction of the initial lesson for this introductory week. This was week 1. What I now can say is that it's very easy for, I think, all levels of learners to use story maps. They're pretty user-friendly for people that are used to doing online type of work. it's difficult to engage faculty who are not familiar with GIS or Esri. There's a lack of administrative support, but it does easily teach a unique method of visual communication, which is very important, as we all know. And it can be used as a tool to actually create your class lessons and tell that story as well. So with that, thank you. This is myself with some students, and I think you recognize the other guy.
Thank you, Dr. Torro. That was very inspiring. I wanted to share with everyone here, and including you, Dr. Torro, just an article about another environmental science professor at Villanova last year who kind of had to reinvent his class in environmental science, and he used insights to do that. So it was a nice article that we wrote last year related to the topic of pedagogical approaches. So I just wanted to share that with you as another possibility you could consider. So finally, we have our final presenter, and that's Dr. Sita Salyap-Aika, and she is a GIS science researcher and lecturer at UMass Amherst, and she specializes in teaching a GIS intro course all the way up to programming and GeoViz. So she's going to talk about what she did in some of those programming classes in her curriculum. Thank you.
And thanks for a nice introduction, Rick, but I somehow cannot turn on my video. It says it's turned off by host. So would you mind?
Oh yeah, let me see if I can
putting
turn
a face
it on.
on my presentation.
Okay, I think Zach, is there a way that you can do that?
She will just have to turn back on her video in the
Yeah,
bottom
it
left.
says I can't because the host stopped it. But so I don't know. Okay, well.
Yeah. So Zach, what she's saying is it's not giving her the option to start video. It's saying it's.
Let me show what it says here. Because I can share my screen, right? You can see my screen. Okay, start my video. Great. All right. Welcome everybody. My name is Sita Salyap-Aika, and today I will talk about the MapyPython diaries. But let me first show a brief summary of my own background. It's a personal diary, sort of educational, and how I got involved in GIS. I love talking about special connections, and I'm sure most of you do. So this is going to be another method diary somewhat. I am from Turkey, and I did my bachelor's, Master of Science, and double minor in Midwest Technical University. It started as a quite qualitative and STEM heavy journey in the beginning. So what happened, and I ended up in Southern California. So it wasn't the weather, which might have been a quite valid excuse, but somewhere around my double minor, I fall in love with GIS, Geographic Information Science, and maps, but not the ordinary maps, the intelligent maps. And you can find anything you can ask, like a crystal ball, the fortune tellers use, and the programming. It was so fascinating for me to see or to rule the computer in a Windows 98 era. So I went to Southern California to complete my joint doctoral PhD at Department of Geography, and I learned a lot more to share, and I decided to stay at academia to share what I learned and have been learning. Now, you might not notice, but I'm in Boston area, not in Amherst. UMass Amherst has a satellite campus called Mount Ida, and is where I physically teach in a non-pandemic world. But this doesn't mean that my courses are only limited to Mount Ida, so you can follow them synchronously and asynchronously. So I was teaching multimodal even before the pandemic. And now everybody knows those terms pretty well, right? What I teach Introduction to GIS, GIS Programming, Geocomputation, Cartography, Geovisualization, Special Decision-Making and Support, and Web GIS, mainly anything related with special information, also known as GIS. What I teach is very gritty and like to be fed by the research. And I feed my teaching, my research by research, which includes special models, uncertainty and sensitivity analysis, and geovisualization. So today I will focus one side of the spectrum when teaching, and one course particularly that I talk about in the previous slide. It's GIS programming, which is a course begins with the very basics of Python programming and continues with model building and ArcPy. And this course was designed by my favorite GIS colleague, Dr. Forrest Bollig, and I had the chance to teach it for the first time during the fall 2020, which is the semester known as the first official known to be remote semester ever. And teaching programming in remote, well, you might think it should be hard for somebody who shouldn't be hard for somebody who teaches multimodal, right? Well, it's not true, because I was teaching remote, but my students had access to a computer lab, but they were using the campus facilities. But this remote teaching, not even close to that remote teaching. So the question and the terror of anxiety hit simultaneously. I spent the summer 2020 trying to come up with ideas to find opportunities to students to overcome of the challenges of accessibility in places where software and hardware scarcity exists. Therefore, I revamped the existing GIS programming course. I started with a flyer first, trying to welcome students to this new era. I even included a Twitter account, which is not quite active, but it is there to share the course-related news and some other GIS programming-related tweets too. Well, you already have the spoiler of the presentation that I revamped the course, but I know that this session is full of awesome educators too. So I am curious to learn your opinion, and I am sharing the Jamboard, which should be accessible to all of you. And I put the chat. Okay, great. I'm seeing people are jumping already. So if you have time and if you have used the Jamboard before, please feel free to share your challenges in teaching programming. And if you haven't used and not familiar with it, feel free to type in the chat and I will read it later. So everybody has different challenges when teaching programming, obviously. However, when I was trying to manage my schedule with my personal life and teaching load, my first reaction was my students won't be able to access computer labs. And what if they don't have a good system at home? What if they won't be able to install, run, and test the various software? There are some cloud options, but I want something simpler, plus something that can be carried to their career as a skill set. And after all, they might end up with a company where they won't have that accessibility to cloud servers or etc. And today, when I was listening to Dr. Kay Parks from University of Southampton about resilience of resilient GIS education, Dr. Parks mentioned that reusing and recycling materials, and this is what exactly I was feeling when I was converting everything into Jupyter notebooks. So first, I made myself familiar with the technology of Jupyter notebooks because I have been using Python for a very long time, but I never did before with the Jupyter notebooks. I also looked at the GitHub repositories and my binder as well. And I tested those links on my friends, my relatives, people that has never used Python before, and they were working. Well, sometimes building the whole environment took very long, but it worked at the end. And this made me every example accessible with the browsers and mapping possible through the ArcGIS Online too. And the creators of the Jupyter notebooks are not just genius about what they're doing, but they also come up with their main real links, three important things. The first one is the languages that it supports, Julia, Python, and R. Second one is the planet Jupiter itself, which evokes the traditions and ideas of science. And last but not least, Galileo's discovery of the moons of Jupiter. And it's not an ordinary publication, but it is a reproducible research since Galileo also provided his data too. So all of these inspirations are actually important in the Jupyter Notebook because it become my key source while I'm sharing my examples. And in order to start with notebooks, you can either get Jupyter through Anaconda or ArcGIS Pro. And once you get it, you can create your own documents, include code cells and markdown cells with the available buttons on your network. And it works on any browser. And now you're seeing a demo on a Google Chrome, for example. The file extension is IPYNB, and doesn't make sense if you open in a text editor because it's full of markdowns. And you can, the beauty is that you can upload your notebooks in a GitHub repository, and you can create code cells where you can type of your Python code too. And how about ArcGIS Pro? As I mentioned, it's possible to use them inside ArcGIS Pro too, with the capability of running notebooks in a single button click from the insert ribbon. And you can use existing notebooks or write your own. Also, you can use ArcPy smoothly so that you can write anything you do within the tools inside a notebook too. I mentioned about the GitHub. So what is a GitHub repository? It's an online place that you can upload your projects and you can collaborate with others and track your work. Mainly, it's a place you can put your files, in my case, all of my notebooks, so that I can share with my students. And so far, we have notebooks online, but they are only readable up to this point. The question is still persisting. How are students going to run them? And the answer is Binder. It is a GitHub repo. It turns GitHub repos into a collection of interactive notebooks. And if you have a repository full of Jupyter notebooks like mine, with Binder, you can enable those notebooks, open an executable environment, which will make your code immediately reproducible by anyone, anywhere. And if you have complex dependencies, like special libraries necessary to run some of those notebooks, then you should include in the requirements text document too. But before closing, I would like to also share another bonus that I love using. I tweet the famous saying, stand on the shoulders of giants, like rise on the shoulders of giants, because I truly believe this is how Rise makes you feel when you're using in your notebooks. With Rise extension, you can turn your Jupyter notebook into a real presentation where you can edit, code, and run your script on your slides. You can specify the order, how they're going to see inside a slide, and arrange however you like. And meantime, since we're almost out of the session time, I'm just quickly copying the links that I will show in a second. Okay. First of all, thanks for your attention, and I'm happy to answer any questions if you have. And if you are into using notebooks inside ArcGIS or not, please feel free to check these resources and feel free to keep in touch with me. And I provided my email, and we'll be happy to help anyone who's into.
Thanks, Sita. That was an awesome presentation. Anyone have questions for any of our presenters? We have a couple minutes. Okay, yeah, I just wanted to quickly share kind of a closing slide, if you will. And really, this is just something that I want to make everyone aware of. And we heard a lot about in Miriam's presentation, her work with the Learn team. And for those 64 attendees, hopefully visiting learn.arcgis.com is not new to you, but if you haven't, I highly recommend checking out that resource. And then just as a kind of a nod to Sita's presentation, we have a specific gallery on notebooks just themselves, and I'll be sure to put these links in the chat here, and also the evaluation survey. And enjoy the rest of your conference, and have a great evening. Thanks.
Thank you, everyone. Thank you.
Thank you.